Okay, your job is to make sure that you have a copy of this anchor chart made. To verify that you did it, some students might choose to do this on paper so that they can refer back to it, but I'm going to make sure that you have this somewhere on Google Classroom so that you can access this. My students at school will have this on paper in the classroom to use to help them. So the first thing that we're going to do is copy these words into each square: commutative, associative, identity, and inverse. So hopefully you can spell it better than I did. Identity and inverse. The middle says properties of operations. So basically all I'm doing is coming over here and I'm putting these words and these examples where they're supposed to be. I have copied what is in each one of these bubbles into the spots over here. And we're going to give some examples. So 3 times 4 also equals 4 times 3. And it also says 3 plus 4, 4 plus 3. So I'm going to do the same thing. 3 plus 4 equals 4 plus 3. There are a couple of little rules that go with it. What it says is numbers can be in any order, and the answer will be the same. So numbers can be in any order, and the answer will be the same. I think of this as commute. You go back and forth, like in a little car, you commute back and forth to get from work to school, you're still getting where you're supposed to be. So that's something that I think of. Associative, it has to do with these parentheses. You can group the numbers differently, but the answer is still the same. So this works with addition and subtraction, or adding and multiplying. So the numbers they used was 7, 6, and 8. So 7 plus 6 with the parentheses plus 8 will still equal, if I shift those parentheses from one side to the other side, will still equal 7 plus 6 plus 8. 8, well, that should be an 8. The answer will be the same. That works with multiplication as well. I want to make sure they have the same numbers. So they have 7 times 6 in the parentheses. Oops. And then times 8 will equal 7 outside of the parentheses times 6 times 8. That is an 8. And what the little phrase says is you can group the numbers differently. The answer is still the same. You can group the numbers differently, and the numbers are still, the answers are still the same. Sorry. Okay. Oh, let's see. I think I put my multiplication and addition in the wrong place. Oh, great. So we're going to have to move these. So what I'm saying is, you notice that I have a little line through here and I have a line through here. So associative is a little, yeah, so we're going to have to flip these. Yeah, so I am going to copy and paste. So Control C, Control V. Is this one, I have an oops. So this is inverse, which really stinks because these two go together and those two go together. But It is what it is. I'm not going to redo everything. All right. So the associative property works like so. So think of those two together and those two together. I apologize that it doesn't match this perfectly, but I made a mistake, and we all know that that happens from time to time. So you will want to fill in the bottom and fill in the rest with the identity. Identity works with addition and multiplication, but they're a little different. So identity, what it does is it makes the same number come back. So its identity is yourself. Identity is you, is your number. Is if you're 4, then you're still 4. If you're 6, then you're still 6. If you're 12, then you're still 12. If you're -4, then you're -4. But the things that happen with identity with addition is different than the same things that happen with multiplication. So let's get into that. So identity of addition is on the top. So that means that any number plus 0 will be, and I think they use the same thing, the sum of any number and 0 is that number. So that any number plus 0 will be the same number. And again, their phrasing might be different. The sum of any number and 0 is that number. Mine is pretty close. So the examples would be 6 plus 0 equals 6. -4 plus 0 equals -4. So it's identity. It stays the same number. Identity of multiplication is, I'm going to make sure I use their words, any number and its opposite. Nope, wrong thing. Multiplication. Any number, the product of any number and 1 is that number. So the product of any number and 1 is that number. So the product, which means multiply, of any number and 1 is that number. So examples. If I have -18 times 1, I get -18. Get the same number back. If I take 104 and I multiply it by 1, I get 104. So identity means it keeps its own identity. It stays the same. But addition is plus 0. Multiplication is times 1. We have talked about inverse before, but we're going to go ahead and define it back here. So the inverse of addition is any number and its opposite added together equals 0. So any number and its opposite added together will equal 0. And some examples that they use for that is 3 minus 3 is 0. That's pretty easy. 3 minus 3 equals 0, because those are opposites. You could also do -3, which is the opposite. What is the opposite of -3? Positive 3 equals 0. What you want to see is that that's technically positive 3, and this one is -3. So they're both opposites. Now, multiplication, I've told you that it's the same, the inverse is division, but they're going to use fancier words, but you just need to remember it's division, because students get stressed out when they say fractions. So any number multiplied by its reciprocal is equal to 1. So any number multiplied, I wish I could spell, there it goes, by its reciprocal is 1. So inverse and identity kind of go together, because identity makes it give you your number back. Inverse will make it be 1. So they're a little similar, but they do different things. And we're going to have some more lessons on this, but I just want you to get it on the paper right now to make it make sense. Some examples for this is 2 divided by 2 is 1, or 2 times 1/2 is 1. So like I said, it's division. So if I do 2 divided by 2, well, divided by 2 equals 1. That is the same as 2 times 1/2. And 1/2 is that reciprocal. Again, we are going to have another video that explains this, or another lesson that explains this reciprocal portion of it, but in the big picture, that's what you need to know. So you want to have this somewhere. If you choose to do it on paper and match this, that's fine. Just make sure you tell me in some way that you have this somewhere to refer back to.